Hello, my name is Deska, and I'm a game developer. Welcome to the third and fourth week of my challenge to make as many games as I can in 2021 to help me learn the Unity engine. This fortnight, I wanted to focus on one concept in the game, which I chose to be 2D controllers. This fortnight had me doing more research than developing a game. I wanted to see how a lot of 2D and 3D platformers build their controllers, and what advantages and disadvantages each have. There are a few ways you can do 2D controllers in Unity, and the main two are a physical rigid body controller and what I call a transcast controller. Like I said before, both of these have advantages and disadvantages, and you have to analyze each of them and picture how they fit into the puzzle for your game to determine which one is best for you. This week, I decided to build a small platformer around the Transcast 2D controller. It's got a few levels and a few key gameplay elements to spice it up and make it fun. The 2D controller works by using user input, transform translation, and the 2D physics raycast function to detect collisions. You might ask, why don't you just use a 2D rigid body controller so you don't have to worry about collisions? Well, in my experience, 2D rigid body controllers' movements can be unresponsive, unpredictable, and janky, all characteristics that are not desirable for a platformer. Platformers typically require snappy and hyper-responsive controls. Think games like Super Mario Odyssey, Super Meat Boy, or Spelunky. Games like this thrive with responsive and easy-to-use controls. This is a major advantage of the Raycast translation controller as opposed to its physical rigid body counterpart. The Transcast controller works by firing rays from its collider's bounds. The origins of the raycast are offset inwards by a skin width to ensure if the collider is sitting flush with another collider, the rays don't just pass through and not register a result. These raycasts are then tested for collision, and the collision data is stored in a struct, setting Boolean condition values to either true or false for the side the collision is detected on, top, left, right, or bottom. The velocity of the object is then set determined by these values. For example, if a collision is detected on the bottom of the controller, we can be sure that there is an object below us, thus we must set our y velocity to 0. The same goes with any horizontal collisions with x velocity. I've also given the player the ability to jump, which entails a simple change in y velocity, and the ability to stick to and jump off walls, to give the game another dimension of challenge. There are only 5 levels in the game. Each gets progressively harder than the next. Towards the end, you encounter these annoying boxes that kill you if you collide with them, forcing you to restart the level. All in all, I learnt a lot from this 2-week challenge. Giving me the extra week definitely helped me flesh out the concept some more and iron out the problems or undesirable mechanics. Which led me to the decision to take a month for my next challenge, from the 1st of January to the 1st of February 2021. And for my next challenge, I'll be focusing more on providing the player with some actual gameplay, enabling them to do a lot more and make more decisions. I really hope you enjoyed this development update. Feel free to head on over to itch.io to play the game. Be sure to give me some feedback on one of my socials I've linked in the description. I hope to see you soon. Cheers.